I'm Tom Hensley, City of Kingsport Wastewater Treatment Plant Superintendent. We're going to take you on a TV tour of the plant today so you can understand a little better what goes on here. We'll go over to the influent pump station now. First step in treatment here, we've got a bar screen building over here that removes any larger trash that we don't want it going through the plant, through pumps. So once it passes through there, it's over here to the influent pump house where we have 6 influent pumps that are capable of about 9 million gallons a day each. And those pump it into the wastewater treatment plant where the treatment continues. Our next stop after the influent pump house is the grit removal system. And it's trying to remove the fine particle grit material. Eggshell is a perfect example. And by vortex action, it's pumped up through the water and then into this truck, which is disposed of at the landfill. We're over here now at the primary basins, which receives the flow after the grit structure. We have 3 primary basins here, which handle about 8 million gallons a day. And here at these basins, we're trying to let gravity take place. Material that wants to float, material that wants to sink. There's a flight mechanism that goes along the surface and pushes the floatable material down to a scum hopper. You can see how the drive system moves the chain and pulls along the flight at the surface and then along the bottom back to the sludge hopper. And it would be rotated to allow the scum to be to flow into this, and then from here it'd flow to the scum hoppers for removal, which those solids are then moved on to a gravity thickener, which we'll visit here shortly. The weirs at the end of the primary basin allow the cleared effluent from this basin to move on to the next process at the trickling filters. I mentioned that the flights move the floatable materials down to a scum hopper, and what we do to keep that material out of our anaerobic digesters is pump it out of the scum hoppers with a truck. Something probably a little different than a lot of plants do, but we find that it causes helps prevent more problems. You're looking at the trickling filters now, which take the effluent from the primary basins. That water is going over about 6 foot depth of rock, and there's a biofilm that grows on that rock that removes nutrients out of the water. And the arms are turning by just the force of the water coming out of the nozzles. There's no pumps or electricity used here in this process. Here we're at the aeration basin, and this receives the effluent from the trickling filters. It's about 2.5 million gallon tank, and the water takes about 4 hours to go through it once it enters. Here we depend on the bacteria to do the treatment for us, and we monitor what we call a mixed liquor, and we also monitor the dissolved oxygen, which is pushed into this basin through fine air diffusers. Here's one of our 4 final clarifiers that's full at the moment, and the water again comes in from the aeration basin into this center well, and from there it eases as calmly as possible out into the clarifier where the solids will settle out. This tank's about a 1 million gallon clarifier. Here we have our new number 4 clarifier, which is our largest, and as you see now it's empty. We've got, you have a sweep that travels the floor that brings the sludge that settles out in the clarifier to that center hopper well. And from there, it would be processed into the digester. We're here at the 100-foot diameter anaerobic digester, and this receives the solids from the primary basins, from the final clarifiers where we have some of those solids that we want to waste out of the system. And here we depend on the bacteria to further break this down for us. We just give them some additional heat by doing that with a boiler. The boiler actually runs on the methane gas that the bugs generate in this anaerobic digester. And behind me you see 2 of the large pumps that mix this 100-foot digester. And between the heat, the mixing, and a regular feed, they're real happy, and we don't have to purchase any gas to run our boiler. We're in the dewatering control room, and here we're taking the solids that were wasted out of the system. And how we do that is we have 3 centrifuges, and this room is manned about 50% of the time in order to monitor that process. Over here we have the controls. We monitor the speed that the centrifuges are spinning, the polymer dose, and the polymer is a binding agent to bring those solids together. As the centrifuge throws those solids out, you need something to help develop what we call a cake. And that cake is then disposed of at the landfill. The cake's about a 23% solids, and the rest of that is water, but 23% is pretty good, basically an industry standard. What you see behind me is our UV chamber. About 5 months ago, we began using ultraviolet technology to disinfect our wastewater. So this water would be from the final clarifiers, and we were using chlorine gas and went away from that technology. And this equipment's going to be able to allow us, once it's all completed, to treat a peak of 35 million gallons a day. There's going to be 24 ultraviolet modules. Each module has 16 lamps, and the water passes by the ultraviolet lamps and is disinfected at that point. We're now in the wastewater treatment plant's lab, and here,
This is a critical step in the process.
Yeah. We're now in the wastewater treatment plant's lab, and we depend on the data that we generate out of here. It's very important to run the plant. We run about 12 tests daily, and a lot of other data collection that's recorded here. And with these lab tests, we're able to make decisions on process control, and we track these for the entire month. We have a state permit that we have to meet, and so we have limits that we compare to our daily test in order to. Well, I hope you've enjoyed your tour. We're now here at the final discharge point for the city's effluent. It's back in the river and on to beneficial use, swimming and drinking water, and all the things that we need water for.